Thanks for having me today, and good morning, everyone. My name is Brian Russell. I'm the business line manager of foray for Revit. I've got over 20 years in the architecture, engineering, and construction industry. I'm a former BIM manager or Revit implementation specialist for the last 12 or so years of my life. Prior to rejoining Chaos Group, I worked as a BIM manager for a 180-person architecture firm here in Baltimore. And there's my email address should you have any questions. After the presentation, please feel free to reach out to me. It's brian.russell@chaosgroup.com. I'd be happy to answer any questions that you have. So, brief agenda for today. I'll keep this relatively succinct. I'll do a brief product overview. Let everybody know why we chose to do what we did with foray for Revit. We'll talk a bit about the simplified user interface and user experience that we've developed for foray for Revit. Chat about some specific camera effects that are built into the product. I'll introduce Swarm, which is our new distributed rendering engine that ships with the AEC verticals. That's foray for Revit, foray for SketchUp, and foray for Rhino. And we'll touch on the standalone VR mat editor and what that might mean to your workflow. So going back a few years, we sat down and decided we were really going to, in earnest, develop foray for Revit in a way that made a lot of sense to everyone. And so to do that, we wanted to interview and chat with a lot of the top firms, architecture firms, engineering firms, and construction firms throughout the globe. And so we've done that, and through that interview process, we found some very clear directions on what the product should be. One is that it needed to be accessible by designers, not just visualization specialists. We needed to greatly simplify the interaction. For those of you who are familiar with foray for 3D Studio Max, 3ds Max, excuse me, you'll know that we've got a lot of different options in there, a kind of infinite adjustability, if you will. With foray for Revit, we had a very different plan. We needed to greatly simplify what it took to get in and start to render. We needed to be able to get good results, and we needed to be able to get those results quite quickly. So good results make it fast. And so with that, we really started to look at, well, what do most designers do in terms of rendering, and do they do animation? What do they do exactly as they go along? And this is part and parcel of what most of our designers said they do day in and day out. And this is a model in white. The focus of this particular type of image is so that you are looking at form, you're looking at light, you're focused on the overall look and feel of the building without getting caught up in what the materials are that make the building up. So early in your design process, this is the type of rendering that most of you have said that you're producing. And as you get a little further along, maybe you're doing something like this. This is, again, an override material. This is direct output from foray for Revit. And what you're looking at here is a subsurface scattering SSS2 material that's made to look like a 3D print material. And so this type of material would be used before going to a client presentation where, again, you're studying light and form. And in addition to bringing a 3D printed model along, you'll do a handful of renderings that look something like this and bring them along as well so that you're telling a consistent story with consistent visual imagery. So part of this discussion is understanding what we mean by designer versus visualization expert. And immediately the knee-jerk reaction that I get when talking to visualization experts about foray for Revit is, well, what does this mean for my job? And I'm happy to report that this doesn't mean their job goes away by any stretch of the imagination, but our goal here was really to focus on putting together a product that would help the visualization expert in what they do and free up the designer to do what they do best, which is focus on design. So imagery from a visualization expert, for example, might look something a bit more like this. And the thing that the visualization expert is really good at is composing a good camera, setting the scene, doing post-processing effects. You can see some snow in the foreground that's got a little bit of blur on it. That's obviously been done in Photoshop. Some tweaking to the lighting, some very specific texture mapping that they're using here with knockouts for the snow on the roof and using displacement for the snow on the ground, things of that nature. So again, this is 100% Revit, but it's had a lot of work done to it very early in the process by a visualization expert. This takes a lot more time to produce this level and quality of image than what we would get in, say, a designer's image that's just trying to make a design validation decision. Is this the right light for the space? Do I have enough glazing on the south-facing wall or too much on the south-facing wall? Help you understand what some of those decisions are. So visualization is a part of that entire pipeline. And what we've done with V-Ray for Revit is really made it accessible to designers. If you look at V-Ray for Revit under the hood, you're going to see settings that look something like this. This is an export of our settings under the hood, in fact, from V-Ray for Revit. And these settings for the Max guys, this is very familiar, minimum and maximum subdivisions, DMC sampler thresholds, etc., right? If you're a designer, you don't want to be worried or bogged down with what these things mean. You don't want to have to go through 2 years of school in order to figure out how to use a renderer. You just want to hop in and do your rendering. And to that end, what we've done is met with our top designers, our top visualization specialists, not only in the AEC world, but also in the visual effects world, and we've said, look, what are your best settings? What do you use when you need to get a quick rendering out that's high quality? And through that process and gathering that data, we normalize the data into something quite simple. And so in V-Ray for Revit, what you're looking at here is the user interface, and you can see that we now have just quality presets defined in there. Draft, low, medium, high, and very high presets. So these are baked, and again, we've taken the best settings that we can for any given object, and we've placed them into draft, low, medium, high, and very high. So the designer doesn't really need to get caught up in what those settings are. They know if they choose draft, yes, the image is going to be a little bit noisy, but they're going to get it very quickly, and overall it's going to look pretty good. So later on in the broadcast, I'm going to do a live demo, and I can show you some of this so that you get an idea for what we're doing there. What's under the hood? We're using the new V-Ray App SDK 1.0, so for the technical folks out there that have an interest in this thing, what V-Ray App SDK is it's a wrapper around the V-Ray core that ships with 3D Studio Max. V-Ray for 3D Studio Max, excuse me. So we're always on par with whatever the core version is. So as it gets updated for V-Ray for Max gets updated, we're updating V-Ray App SDK and ultimately V-Ray for Revit, V-Ray for Rhino, and V-Ray for SketchUp will all settle on the same core. So this is our plan, and V-Ray for Revit is the first product that we've developed on top of the V-Ray App SDK 1.0 release version. And if you have an interest, you've got a product, for instance, out there that you would like to extend with V-Ray, you can actually do that with the App SDK. We do sell that as a separate product. Although it's generally a different audience than I probably have on the line here, it's good that you know this. We're using the latest V-Ray Core 3.4. That means you get all of the latest tools and toys that are in V-Ray Core, including the new denoiser, which we'll touch on here in a little bit. In addition to that, we're also utilizing the Autodesk Revit API that ships with Revit. One of the new directions that we had with this product is that we really wanted to greatly simplify the way people do licensing, the way they check licenses out. If you know V-Ray products and are familiar with them, then you know that traditionally we've used the dongle. I'm happy to say we still support the dongle, although our new effort really has been behind online licensing. And with that, we ship V-Ray for Revit with the new online license server that you see projected on your screen. This allows us to see all of our products at a glance, and we can go in and check out a license to go on the road from any one of those products. It's very easy to use. And again, if you have a dongle or an existing license pool on a dongle, You can plug that in and the online license server will actually recognize the licenses on that dongle as well as your new online licenses as well. So this will give us kind of ultimate flexibility in the future. It will allow us to do things like rent licenses in the future or add licenses to your pool hopefully in the future with limited difficulty. Diving right into the V-Ray for Revit product, we really wanted to focus on integrating into Revit in a meaningful way without being destructive to the building information model. So rule number 2, if you will, if rule number 1 was keep it simple, rule number 2 was we always have to be non-destructive to the BIM. Job number 1 for most architects, engineers, and construction folks out there is get the documentation done. We're very aware of that. We understand the importance of that. And so really what we wanted to do was use the cameras that are already in Revit and extend them, make them do things that they can't do inside of Revit natively. So to that end, we've got a great exposure value and a great way of using exposure value inside of V-Ray for Revit. And what you should be seeing here is a video. Everything is now on a slider. You can see exposure value has a slider. You can slide it up. You can slide it down. I'm blowing it out and kind of bringing it back a little bit here. But what this allows you to do is actually see, using the RT render option, for instance, in V-Ray for Revit, you can see in real time any changes you make to exposure value. You can also type in the box. So if you know what the exposure value is or what it should be, you can simply type those numbers in. Same thing applies for white balance here. If you want a cooler image or a warmer image, you can adjust your white balance right here inside of the camera settings in a very easy to use way. So again, you're looking at RT implementation, but these same tools apply to the production render that ships with V-Ray for Revit as well. In addition to that, we wanted to be able to do something with depth of field, and the reason for this is to get people to focus on specific details, also to add a little bit more to the renderer. Again, while we're heavily focused on making design decisions, we still want to be able to give the end user the ability to get in and make adjustments to depth of field if they want to focus on a specific part of their building or they want to show something to a client that maybe looks a little better than just their iterative design renderings. And so we've implemented a slider that allows you to adjust the defocus amount. I've set it way up there so you can see what's happening. And then you simply set your focus distance and adjust the amount of defocus, and it will effectively handle all of that for you underneath the hood. So set your focus distance. In this case, I'm using, I think, 40,000 millimeters. The units that are built into your particular project, whether they're imperial units, feet and inches, or metric units, will read directly out of the file and match. So focus distance here is set to metric millimeters because that's what the central file happens to be set at. We also have, and a little further in the video here, we'll show optical vignetting. And this allows us really to get in and adjust the amount of vignetting to the scene itself. Let me see if I can speed this along here just so you can see an example of vignetting. And as we change the vignette amount, you'll see this kick in just a moment. You'll start to get a darkening around the outside edges. Again, just to add something a little more to the overall look and feel of imagery. So if you are just outside of your client meeting, you need to make a quick adjustment and render it and then run in to your client meeting and show off the image. You can do that. You have that ability built into V-Ray for Revit. The next thing that we wanted to do is really look at a virtual reality implementation that made sense for designers. VR is a huge thing for architecture, engineering, and construction. And probably I don't need to say that, but I will. One of the great benefits to VR is that it really allows designers to do the best level of design validation possible, and that's that they can really see scale kind of firsthand. And they can very much study light and shadow and materials even from a proper perspective. And so inside of V-Ray for Revit, we really have a one-click camera type, and it will convert your camera directly into a cubic VR camera. And it will do either 6:1 or 12:1. That's 6:1 left channel and right channel based on your particular needs. So if you're going to go to Google Cardboard, for instance, a 6:1 image might be all you need. If you're going to go to a Samsung Gear VR, you may need a 12:1 so that you can get stereo pano output, and we do support that as a camera type directly in V-Ray for Revit. So you just select the camera, hit render. It's automatically going to use your height, and from there it will render out the image that you need. You save that out, drop it into your device, and you've got VR ready to go. Time to design validation at draft level, you can get from render to headset in less than 10 minutes, which really allows you to do some exciting design validation that you wouldn't otherwise be able to do. This is V-Ray Swarm, and for those who are somewhat familiar with our old distributed rendering model that ships with Macs and that are familiar with the distributed rendering model that was in SketchUp and Rhino, we heard a lot of feedback from our AEC clients that said, look, this is great, but it's really difficult to set up. It's hard to update. If I'm in a position where I've got a new version of V-Ray for SketchUp and an older version of V-Ray for Revit, for instance, I have to update to the latest in order to make SketchUp work, and now I've broken V-Ray for Revit. How do we solve that? And so to that end, we set out to develop at least a stopgap prior to getting into V-Ray Cloud, technology that would allow you to do distributed rendering in a much more meaningful way. And we call that Project Swarm. In this case, V-Ray Swarm is set up so that it's an executable. It just gets administered to any of the computers that you'd like to use as render nodes. It uses the Universal Render Node license. You get one of those licenses with V-Ray for Revit. There's also some package deals, I think, where you can buy V-Ray for Revit and like 5 render node licenses for Swarm, so you can render on up to 5 computers. But one of the great things about Swarm is that it really is designed to be elastic, and I know that's a buzzword and lots of people use it, but really it is elastic in every sense of the word, and here's what I mean by that. You can take V-Ray Swarm, install it on all of your production machines, whether it's 5 machines, 2 machines, or 100 machines. It doesn't matter. If you've got a receptionist at the front desk, you can even put it on their machine. As they work, V-Ray Swarm is working in the background on their computer, and it's observing how they're using their computer. If they need more processes, V-Ray Swarm lets those processes go. If they need less, V-Ray Swarm will use those processes. So what we're doing is effectively allowing you to use the majority of the computers that you already have as processing power. You're paying a lot of money to keep those computers on and running, but not using most of the processing power that you have there. And I think it's something like you're using about 25% of your processing power at any given point in time. So that leaves 75% that's sitting idle that you're paying to keep powered on. Swarm's going to make the use of that 75%. And in fact, if you get up and go have coffee, Swarm's going to use the rest of it. When you come back from grabbing your cup of coffee, then Swarm's going to let those processes go and move on to the next thing. One of the other great things is that it allows peer-to-peer distribution. It actually is set up to do peer-to-peer distribution. So if you're familiar with our old distributed rendering, you would have to send a VR scene out to every single one of your nodes. And it takes a lot of time and a lot of network traffic to send, let's say, a 1 gigabyte VR scene out to every single one of your render nodes before it could kick off rendering. So it was very slow to start. And then if something was missing the assets, let's say it didn't get all of the imagery that it needed, you'd have to resend the VR scene to that package and re-render the image because buckets will get dropped. Not a very convenient way of doing things. Swarm does away with that issue by using peer-to-peer, and if a bucket appears to be blank, it's intelligent enough to understand that the bucket isn't rendering correctly. It will drop that bucket and another machine will pick it up and render it. So it really truly is elastic in that regard. The other nice thing is that this interface that you're looking at actually gets installed on every single one of your render nodes, so you can actually administer your entire network of render nodes from any single one of your render nodes. So I can go to any of the computers that belong to my list of render nodes, and I can manage the entirety of my network from any one of them through the web-based portal. In fact, if I know the address and the port for that particular render node or any particular render node, I can do it from any computer that's on my internal network. So this really is on-premises cloud-based rendering. We give you the ability to manage tags and set license servers. So if you have a license server set up in a centralized location that's maybe off-prem, you can point to those license servers. Otherwise, it will use your default on-prem license server. You can set your own ports, and you can add tags. So if you have, for instance, a GPU machine, a high GPU machine that's got high-end NVIDIA cards that you want to use, for instance, you can do that. You can set that up, tag it as GPU, and people can use that to do RT-GPU renderings. Otherwise, you can set tags for smaller groups of computers that people can set up and render to. And I'll show you a little bit of this here in just a moment and how that works once we're inside of V-Ray for Revit. But effectively, everything is on a slider, and we just adjust how much of the total network resources we want to use for any given tag, and that's it. It will use whatever's available to it, render very, very quickly. We're doing 4K images in some cases in a matter of minutes, which is absolutely amazing. So you can do big images very quickly if you decide to do that. The other thing that you can do is, again, from any computer on your network, if you have the address for the rest of the computers that are on the network as render nodes, you can see what's going on with each one of them in terms of their CPU utilization, GPU utilization, memory, network, and hard drive. So you can see how much space is on any one of them. So you really get granular, and this is real updates in real time, so it really does monitor all the processes that are happening on any given machine and shows you how things are being utilized on that particular machine. So this is Swarm. It typically generates a fair amount of questions, and I'm happy to answer them as we go along towards the end here. But be on the lookout for Swarm. It's really powerful, and we think it really does change the game in terms of multi-processor imagery and on-premises cloud-based solutions. Swarm is doing that for us today. Ultimately, we will have a cloud-based solution that's off-premises available. It's going to be very similar to the Swarm implementation, but we'll probably have some way of queuing your jobs, things of that nature. That'll be happening in the future. We don't currently have Swarm out for 3ds Max or Maya, although we have said that it's on the roadmap. So probably within the next year or so we'll have something similar to Swarm available for 3ds Max and Maya as well, or some form of on-prem that'll be very similar to Swarm for those products that will work across the product lines. So be on the lookout for that in the coming year. Some exciting technologies we're working on in that regard. So materials was the one place that we really had to focus on. What is it that we're going to do, and be non-destructive to the BIM at the same time. So materials are important in terms of the way people do their documentation in Revit, but the materials that ship with Revit aren't always necessarily the best in rendering for V-Ray. So we recognize that, and what we've done is we've allowed the end user the ability to create their own VR mats or to do global overrides based on whether or not materials are opaque or transparent, and then allow you to do individual overrides as well. So for instance, and maybe I should back up a second and say that what we'll do is translate all the Autodesk shaders and Autodesk materials over to V-Ray materials at render time. We do that automatically. It happens under the hood. It's not something that you have to do. There's no mapping. It just does it itself. So you can actually adjust the Revit material inside of the Revit material browser itself and get to the end product that you want to get to. but there are some limitations to that as well. For instance, subsurface scattering, you don't have that ability built into the material editor that ships with Revit. You also don't have the ability to do displacement. So if you want to do a really nice displaced grass, for instance, you don't have that ability. So we've allowed you to do that with a standalone VRMat editor, and you can actually open and run this VRMat editor even outside of Revit natively. So the real benefit to this is you can create a VRMat that is either glass or diffuse material that's got a map. It supports all of the things that are supported in standard V-Ray workflow, including trilinear mapping. All of that great stuff is included. And the materials that are created here actually work across the V-Ray spectrum. So you can use materials created here in V-Ray for Max. Likewise, you can open materials that you created in V-Ray for Max inside of this material editor, or you can drag and drop those VR mats from Max or Maya directly in here, drop them in Revit, and override any given material with that VR mat there as well. So we've unified the VR mat platform across our product lines for the most part. There's a handful that we need to update, but V-Ray for SketchUp and V-Ray for Rhino will be coming very soon. They're in beta right now, and they use the same format for VR mats. So if you've got libraries of V-Ray materials, you can update them with the VR mat editor that's here, and they'll work across all those product lines, which is a really great thing that I'm fairly excited about. So this is the live demo portion, and of course I always put in what could possibly go wrong, because inevitably something will absolutely go wrong. It's a known fact that any time that you're in GoToMeeting or GoToWebinar and you start to do a live demo, V-Ray for Revit in this case and Revit don't necessarily get along. So if I crash, I apologize. But I think we should be okay for all intents and purposes. So I want to call out a couple of things here really quickly, and I'm going to hustle through some of this because we're already at 11:30. This is our toolbar. This is our implementation. We're directly integrated inside of Revit natively. We've got a place where you can select your view here in Revit 2016 and Revit 2015. There are some API limitations that keep us from sending a render directly from the camera view, which is a bit of a bummer, but I'm happy to say we've worked with Autodesk, and some others have worked with Autodesk as well. And as of 2017.1, you can now, while you're live in a view, actually send a render. In other words, our toolbar doesn't disappear when we're here and we hit render. So I'm happy to point that out, that that's no longer a limitation from us. But this is where you'll select the view that you want to render. In this case, I'm going to choose from Yard. This is where you can look at the different render options that are available to you. We have three. One is render with V-Ray. This is the traditional production renderer, if you're familiar with V-Ray for Max. We've got render with V-Ray RT. I'm going to say this, there really is very little difference between RT and production render in terms of output today. There's almost no, if no, difference whatsoever. It's just a difference in the render type that you choose. One of the great things about RT is that you get really fast updates on changes that you make to the scenes. So if you make a change to lighting, for instance, that'll get passed through and you'll see the update in RT, rather than having to stop the render as you would with a traditional production render and hit render again. Lastly, we've got an export VR scene option here. Excuse me. And the export VR scene option will allow us to export a VR scene that you can then open up and render in the standalone V-Ray renderer that ships with V-Ray for Max and V-Ray for Maya. So if you've got standalone V-Ray render, or if you've got V-Ray for Max or V-Ray for Maya, you can run the standalone render, and you can actually import the VR scene from Revit, and it will render one for one whatever your setup was inside of V-Ray for Revit. So that's kind of cool. And ultimately, we're looking at what our possibilities are to get a VR scene imported into Max, or a Max VR scene imported into Revit. That's on our roadmap, and it's a big to-do for us. So we're diligently working on seeing what we can do to that end as well. A very simple show hide frame buffer. We use the traditional V-Ray frame buffer, so if you know that from any of the other V-Ray products, we're no different. In fact, we have all the same bells and whistles in our frame buffer that everybody else does. Again, you can see quality settings here: draft, low, medium, high, and very high. There really is no additional setting here. There's no way currently for our Max users to save a setting and send it down to designers to use, but we're looking at that as a future option. However, if you are setting some particular material overrides here or lighting overrides here, we will pull those across, and there's a way to save those and hand them out to other people who might be rendering your project as well. Resolution settings, we try to keep very simple but also use familiar controls. So if you're familiar with rendering in Revit natively, we have pretty much the same setup. There are some presets here that you can select from. You can set custom, and you can either tie the aspect ratio or untie the aspect ratio as you see fit. And then finally, we use the crop region, either screen or printer. That's up to you, and you can set DPI to get your overall resolution. Again, people who are familiar with rendering in Revit natively, this is going to be very familiar to you. Artificial lights, interior lights specifically, is what I'm talking about here. This was a vast departure from all of our other product lines in that we don't have a V-Ray specific light that we place. Again, we needed to remain non-destructive to the BIM. And to do that, we needed to make sure that our interior lights came across and that you didn't have to place 3,000 lights and then go back in and place 3,000 more as V-Ray lights. That doesn't work to anybody's benefit. So what we do is we take whatever light fixtures you've placed in Revit and we convert them to IES files and an IES-based V-Ray light. And again, we do this at render time. So what happens is we will read any IES file that you've specified in your light family. If you have not specified an IES light in your family, we will automatically convert to a generic IES that ships with the Revit product. Excuse me. So V-Ray Sun, again, what we've done here, non-destructive to the BIM. Daylight, sun path is set exactly as you would expect it to be. So if I go into sun path and I go into sun settings and I change my my time of day, and I do a single day, for instance, and I change the place and time of day, that information comes across, and all that we're doing is replacing the native Revit sun with a V-Ray sun. Excuse me. So now that we've replaced that sun, it'll adhere to time of day, and in fact, if you're at dawn or dusk, you'll get those nice colors that you would expect in the V-Ray sky. So in addition to that, we've also included V-Ray Dome Light, and a V-Ray Dome Light will allow you to specify an HDR image. So if you want to light your scene with an HDR image, you have the ability to do that. The only other settings that we would have for the dome light or the sun are the ability to adjust the overall sun intensity. So in this case, back to dome light, you can set the intensity, you can actually set a rotation here if you want to set a rotation. We're continuing to develop the user interface on this, but this will work with any HDR imagery that you have today. I'll set that back for now. Material browser. If we want to do quick iterative model and white studies, that's easy enough for us to do. We go to global material overrides, and we just select using pre-made materials here, for instance. I can go in and select any given VR map that may look the way that I want it to look. So if I want to make it look like a basswood model, I can do that here. And same with glass. I can do that here. Actually, let me come back out and go to glass and architectural glass. You'll notice that we have thumbnails for VR mats now. That ships with V-Ray for Revit, so all your VR mats will get associated properly, and thumbnail generation happens as a part of that. It's really great capability. It takes some time to get good output for thumbnails if it doesn't already have them, but we do a pretty good job of rendering those out. And you also have some override control here for sample size, width, and height. I'll just use these out of the box for now. So what's going to happen is this is going to look through my materials, and instead of translating them all from native Revit materials, it's just going to use these two to override anything that's opaque with wood, anything that's transparent with glass. And with that, I'll just show you really quickly the kind of output that we get. I'm going to kick off a standard render, a production render here. And you'll notice the kind of output that we get right away. It's going to do a couple of pre-passes here, and then it's going to kick over to progressive mode right away. We've got a wood look object in here. We're continuing to improve these materials as we go along as well. So if I want to do a quick study, I want to be focused kind of clay model style on what's happening with the building and lighting, I can do that very quickly and easily here. So I'll go ahead and stop this render for now just to show you again, all the frame buffer tools that you're familiar with, including exposure control overrides, all exist here. So you do have the ability to do those things, tweak those settings. In addition to that, we also have the ability to do compositing, and I'll show you where those things live under advanced settings. Distributed rendering engine, Swarm, I talked about earlier. Our messages and warnings dialog that you're familiar with from Max, we have those. We ship with those. Swarm, we simply turn it on and dial up how much or how little we need. We can adjust this as we're rendering. So if I'm rendering and someone else decides they need to render at the same time, they've got just as much or maybe more of an emergency than I do, I can scale back my network resources and they'll get those network resources made available to them. So with that, let's take a look at some of the camera settings. I talked a bit about VR cameras, and what I'd like to show you in that regard is it's just a camera type. And what it's going to do is it will take the height of your image, whatever your height is set at here. In this case, height is set at 648, and it's automatically going to make the aspect ratio 1, which means I'll get a 648 by 648 times 12 or times 6 image. So it's just going to use whatever you set as your height to produce the image. So that's cubic 6:1. Here's a cubic 12:1. And again, if I hit render here, you'll notice what happens in the frame buffer right away is that it starts to render out a 12:1 cubic image. But again, I'll have the ability to very quickly, very easily bring into any headset that supports this imagery type, or a third-party platform like Iris VR, for instance, that allows you to send it out to an app and use it with a Google Cardboard or some other headset type. So we do integrate across a wide variety of platforms that way, but it's very quick, very easy to get output that's easy to use and do design validation with. I'll go ahead and stop that for now. In addition to that, again, simple sliders for exposure values, white balance, and effects. You'll notice effects is grayed out. That's because we're in cubic imagery mode, so it's intelligent enough to know you can't set vignetting in a cubic image because it won't line up properly and it'll cause all kinds of issues for you. So that pretty much does it, and you set up standard camera or a stereoscopic camera based on what you might want to show in that regard as well. Settings. There are some export settings here for your V-Ray scenes. If you want to pack up all of your materials and what have you as you export, you can choose the export as archive option, and it'll export everything as a 7-zip. You can see our geometry tessellation values at draft low, medium, high, and very high here. You can make adjustments to that based on what your overall model is doing and what you need it to do. Here are our render channels, so you can simply select whatever render channels you might need if you're going to do post-production in Photoshop, for instance. we give you the ability to turn those on and off. We also have our denoiser channel here. For those that aren't familiar with denoiser, it allows you to do low light, for instance, interior scenes that would otherwise be noisy. It allows you to make them clean very quickly, very easily. I suggest using the GPU option here. If you've got any kind of a graphics card, using the GPU option greatly accelerates the overall process and makes it really kind of almost easy to use and get great results very, very quickly. So there are a few options here. You can replace your RGB channel or generate the denoise channel. These are pretty much matching whatever ships with Macs today. And then you can choose to do it as a separate render element or as an RGB channel only. We set these kind of by default so that if you're a designer and you just want to see what it can do, turn it on and it'll render a pass that will allow you to do that. Z-depth channel, again, we support that as well. Sharing, this is where I can put in whatever, or I can save whatever settings I have set for my particular scene, and I can export those settings and then load them into another project on a different computer, etc. Import only selected things like material overrides, for instance, or camera settings. I can just import whatever I need there and render, and I'm ready to go. So there's a way to share your render settings between users. RT settings, again, advanced level settings, typically not what most designers are going to play with, but if you need some level of output here, for instance, you want to do a draft rendering and you want it to time out after 2 minutes of processing on the CPU or GPU, you can do that here. These are our engine settings by default, so you do have the ability, if you're an advanced user, to make adjustments to the GI engine, and again, we're limited in what we allow you to do here, but we do allow you to choose between brute force, light cache, irradiance map, etc. And then the image sampler between buckets or progressive. We found the best and fastest results with these settings across the board, but you may find that you want to use buckets because you're using Swarm and you want to set this at 28 because it gives you really quick results. That's up to you. So we do give you the ability to make some changes there as you see fit. Infinite ground plane we support here and give you the ability to set a V-Ray material or simple materials or colors. We do support probabilistic lights, and V-Ray section box actually just aligns to the section box that ships with Revit. So if you set a section box in Revit, it's in here and it's supported. Aerial perspective, which gives you the illusion of fog at a distance, and environment fog, which will give you some nice effects if you want some low-lying fog in your scene, for instance. And finally, your swarm settings here for multicast, and you can hit refresh here and it'll pull up all the tags. I'm not going to do that because I don't want to ruin the network settings that we have going on with our webcast, but this will go out to all of my render nodes and it'll show me all the tags that are available that I can send renders to. So this is V-Ray for Revit in a nutshell, and I'm just going to show you some of the imagery that we've got available out there that we're producing directly in V-Ray for Revit. This is atmospheric perspective, for instance, in a scene, and you can see that it's almost a heavy fog, but it gives you an idea. We exaggerated it so you could see in this simple airport scene what kind of an effect you can get. This is really great, by the way, when you're doing a city scene or you're doing multiple buildings together in your Revit model and you're up at a couple hundred feet in the air looking down at the city. Atmospheric perspective adds something to the scene that's very nice. Showing you a rather large Revit model. This has actually 4 different central models attached or linked to the main central model. And we've done an override, and that override applies to all of those linked files as well. There's no way to override individual linked files currently, but it does override the whole. So if you do an override material, and this is our whiteboard material that we use, it's real easy to see that the section box, we just set the section box in Revit natively, and V-Ray caps everything appropriately. Finally, the interior scene, again, using just a little bit of bloom and glare as a post-processing effect from the V-Ray frame buffer. Material overrides for the floor. We're using HDR imagery to light the scene. You can see RPC content is natively supported there as well. Really easy to get good results in models very quickly, and that was our goal all along. So that's it for the formal presentation part. I'm going to go ahead and open it up to questions, and as they come across the line, I'll do my best to answer them. And of course, you can feel free to email us if you have any questions. We'll be happy to answer them.
Hey, thanks, Brian. There is actually one question from Matt. It was earlier when you were rendering out that home. He was asking tree families. Well, are tree families being swapped out for proxies at render time?
They're not. We actually support RPC natively. So we're not, we don't have proxy support in this current iteration of V-Ray for Revit. We are looking, it's on our roadmap for V2. And there's some stuff under the hood that we have to change that we're currently working diligently to do right now in order to do that. But we're reading native RPC content directly from the file, and that's what you're looking at there.
Thanks.
No problem.
Let's see, here's another one. What's the minimum recommended spec for a swarm slave?
Well, that's entirely up to you. Multi-core processors are always great, but not absolutely necessary. I take that back. They are necessary. You need at least a dual core or higher. It's a kind of a least common denominator thing. Generally speaking, what I like to do is run a similar spec across my network if possible. For GPU, CUDA related only is supported. We're not doing OpenCL implementation, so AMD processors, unfortunately, in this iteration aren't supported. We're looking at doing that in the near future. Otherwise, if you're a dual core or higher, i5, i3, i7, those are all great processors. They work. AMD's processors work for CPU without any difficulty from what I understand. So there's no real minimum spec there for slave. It'll use it. What I would try to avoid doing is finding yourself in a position where you put a really slow computer up as a render node when you've got otherwise fast machines, because you may hang a bucket for a while on a slower node while it's processing because it takes longer to process. Eventually, if it's too slow, what will happen is I believe it drops out, and one of the faster nodes may take over, but that doesn't always work 100%. So I try to keep it, fairly similar across my product lines. But whatever your production machines are for architecture today, it'll work with most production machines very, very well.
All right, thanks. One other question. What's the time frame for V-Ray for SketchUp update to 3.4 to be compatible with this?
I don't have an exact time frame. I'm hoping to see something in early 2017. That's about the best I can tell you right now. It's coming. It's in beta now. It does, in terms of overall compatibility with materials, we're 1-for-1 right now. We don't have VR Scene import for either of those currently. That'll be much longer on the roadmap, but in terms of having 3.4 out there and in the wild, early 2017 for both SketchUp and Rhino.
All right, thank you. Anybody else have any other questions? Well, it doesn't look like it at this point, I guess.
Okay.
You did such an excellent job answering everybody's questions. They don't have any, right?
Well, certainly if people find that they have questions as we go along, you can feel free to email either of us, either Motion Media or myself directly. I'm happy to answer anything from my side.
Okay.
You know, that's pretty much it.
All right, and
I can hang out on the line for a bit if anyone has any additional questions. There's no problem there.
Okay, yeah, someone's asking if it's recorded, and yes, the answer is it was recorded, and it will be available on the Motion Media YouTube channel, which is just youtube.com/Motion Media LLC. It'll probably be up there by this afternoon, tomorrow at the very latest. So you'll definitely be able to check that out, and if you aren't already on our email list, you'll want to get on there, because when we do other events like this with Chaos Group or Autodesk or anybody else, you'll get notified and invited that way. And of course, anybody looking to actually purchase V-Ray for Revit, you should definitely contact us at Motion Media. You can use that email that's right there, and somebody will get back to you, or else mine is brad@motionmedia.com, and Brian, who's also on this call, Brian from Motion Media, his is just brian@motionmedia.com. So pretty simple. And it doesn't look like there's any other questions coming in. Some thank yous, but no more questions at this point. So I guess I will we'll go ahead and shut her down. But like Brian said, if anybody has any other questions, feel free to email him, email myself, and we can definitely get them answered for you. Brian most likely will, but if you email me, I can forward it to him.
Absolutely, absolutely.
And thank you very much, Brian. Appreciate it.
Thank you. It's been my pleasure. Thanks, everyone. Have a great day. Be safe out there, and happy holidays to you.
All right. Thanks. You too.
All right. Take care.
All right.